Good morning. This is the first session of DBA Fundamentals this month. And today we have Gail Shaw with Bad Designs Have Consequences. I'm sure everybody's had situations like that. Gail's going to show us some real life examples of things that have come back to haunt her or that has haunted other people. So anyway, I've got a few other things to go over first. Our sponsors, Century One, just signed back up with us. They have a lot of good freebie stuff as well as a lot of paid for stuff. But besides all of that, they have some great things on their website that you can go check out. If you want to, you can make a camera impression of this screen and it'll put it on your desktop, and you can go check those sites out later on. We have another sponsor that will be giving a session to explain a few more things about what they do in October, but they have very similar software, but it's across more different platforms, and I think Century One's trying to do that also, but so they may be competing, so I won't talk too much about it, but that's dbwatch.com. Virtual group news. There's actually no new news. We have these discount codes that, let me back up, that we can use, and as always we kind of do go a little bit further with it, and if you use our discount code you'll be put into a pool for a $500 Amazon gift card, and so you could use our discount code to get $150 off, or a discount code to get the 2017 sessions streamed. So that's either one of those is a real nice situation. So if you want to look at those codes and sign up, if you're going to get the $150 off with anybody, you ought to do it with us. And to register for any classes, we're having to go back to our website instead of our normal situation. So go to dbafund.org and you can register for any sessions that are coming up. Upcoming SQL Saturdays. SQL Saturdays are great one-day events close to you. Go to SQLSaturday.com and see if there's anything coming up anytime soon. They're usually totally free, except you have to pay for your own lunch. Other than that, you hear great sessions by great speakers. Here's some of upcoming virtual group webinars. Saturday Night SQL's got one coming up in September by the great Brent Ozar, and that looks like a very good class. Here's the one we've got today, which I think is going to be great. We've got one coming up the 21st, beginning admin, the caring feeding of SQL Server. I don't have it posted up here, but the Down Under chapter has one coming up next week that's on why you should migrate to 2017. So I think that should be a real good topical one. So go check that out. And September 18th, we may have one coming up with Linux fundamentals for SQL Server DBAs. Speaking of virtual groups, there are lots of virtual groups, lots of different languages and lots of different topics. There should be something out there for everyone. We will record our sessions, and they'll be up. They'll be on our YouTube channel, dbafundtube.org or dbafund.org, where you will archive the sessions. You can get to them either way, but if there's any slides or scripts or anything, they'll be here. So anyway, I'm going to turn it over to Gail. Hold on a second. Let me make you presenter. I'm making my intro remarks pretty light this time because I was hoping I wouldn't sniff all the way through it.
All right. Good evening, everybody. It is 7 p.m. where I'm sitting. Dark and still reasonably cold. Still winter down here. Right, so I'm going to be talking tonight about designs, database design specifically. Now, I'm not going to go and start reciting the rules of normalization again. I think we've had enough of those. What I'm going to do instead is have a look at some things which I've seen before. Give you an idea, I've been doing database work on and off now for almost 15 years. It's been an interesting ride most of the time. And in that time, I have seen some reasonably good database designs, and I've seen some reasonably bad database designs, and everything in between. And I've seen a number of patterns that just keep showing up again and again that have got some very unpleasant effects long term. So I thought I'd take you through some of the worst things that I've seen and explain just why they are so horribly bad. I will give you guys a warning quickly. There's no demos in this session because it's a design session. I have some pictures of SQL tables. That's about it. Instead, this is going to be a lot of me rambling about the horror stories and things that I have seen. You know, the back in my day, that kind of mess. Right, so my absolute favorite and probably one of the worst things that you can possibly do to your database are called EAV tables, Entity Attribute Value. Now, the idea behind these is kind of sound. The problem with a relational database is that your schema is fixed. You design your tables, then you put data into your tables. If you decide after 2 weeks of the application being live that you need another column, you need to go and alter the table. If you're working at one of these large corporates that have got complex change control processes, that could take weeks because you need to put in the change request and do the impact analysis and change all the code that touches that table, finally make the change, hope everything went right. Oh, the client wants another new column next week. This is a lot of work. And so what you'll see some people doing is recommending or suggesting or designing a table which doesn't have that problem. Instead of having a shipments table with client ID, priority, and reference number columns, they recommend or they suggest or they design flipping the table around and instead having only 3 or 4 columns. One column being some way to identify what constitutes a row, one being the name of what would previously be a table, one being what would previously be the name of a column, and then the actual value for the column. So in the example that I've got here, I've got 4 rows with client ID, priority, and reference number on each of them with different values. If I wanted to say add to row 1 a shipment destination, I could do that with an insert statement. I wouldn't need an alter table. I wouldn't need elevated privileges. I don't need a complex change control process. I just need to insert another row into a table. And so this is very attractive to those who like schema light or schema-less designs. I generally say that this is a mistake people make once, because it does look very attractive until you work with it. This has a number of rather unpleasant problems. The first one is that it is horribly slow. It's horribly complex. If I want to write, sorry, let's say I had the traditional shipment table with 3 columns, client ID, priority, and reference number, and I wanted all of the rows for client ID of 727. That would be a trivial select statement. Select columns from shipments where client ID equals 727. Done. If I want the same query with this table, instead I need to select from this table 3 times, filtering first for client ID on an attribute. Join that on the row number to the rows where priority is the attribute. Join it on the row ID to the reference number, and then do my filter on the client ID. I've had to do 3 table accesses to get a single row, and it only gets worse from there. If you've got a table with 6 columns, that's 6 joins just to get one table's row. And then you might want to actually fetch another table's matching rows and 3 more tables. Where that previously would be a 5-table join, now it might be a 20-table join. Sure, you're joining the EAV table to itself and to itself and to itself. You're still joining it to itself. It still counts as 20 or 30 tables. Last time I saw this, there was not a single query against the system that came in under 2 pages in size. That's in Word. And the client's main complaint was, this is slow, how do we fix it? Unfortunately, the answer to that is throw away the EAV and design your database properly. Because you can't really index this design. For sure, you can index the attribute column. It's not going to help much because you're not actually filtering for anything useful. There's another problem with this though. If you look at the attribute value column, I've got 2 different numbers on a string in there. That column is varchar 8000 because what else could it possibly be? And so it's entirely possible that by accident or by intent or by bug in application, we end up with a priority of B or today's date. We might end up with a reference number that is actually a date instead of a reference number. We could end up with a client ID that is a 16-character string. We can't prevent that. What I sometimes see with this design is people will have string attribute value, number attribute value, date attribute value with the correct, with say the 727 in the number and the reference number in the string. This is slightly better, but you still can't actually enforce data types. There's nothing stopping somebody from putting a value in the data attribute and the string attribute and the number, and then what does your application do? You also can't put any foreign key constraints on this kind of design, and you can't put any check constraints on this kind of design, which means that the only guarantee that you have that your data is in any way slightly accurate is by trusting and hoping that your developers got all of the validation in their application correct and had no bugs. I've not yet met an application that had no bugs. And as for validation, I'm sure they tried very hard. It's not going to help me very much when the CEO wants access to the database and asks his friends, brothers, nephews, sons, cousin to write him up a web page or connect Excel to the table. In short, this looks attractive because you don't need to do any schema modifications. The problem is, one, dog slow once you get past development level database data volumes. Your constraints don't exist. Your attributes might be completely incorrect. There's a good chance your data is complete and utter garbage and very, very, very slow. Please don't implement EAV. As I've said, it's a mistake people generally make once. I'm hoping that by describing this, I can turn it into a mistake that isn't made none. Because this thing is absolutely horrible to try and fix. So that would be my first horror story of an EAV table. Does anybody have any questions, complaints, or criticisms?
No questions so far. I think you definitely pointed out the problems with that one. So
Sweet. On to number 2. This is a lesser version of the I don't feel like doing my design properly. I've seen this referred to as the one true lookup table. I've also seen it referred to as MUCK, M-U-C-K, and I can't remember what that stood for, but it was just such a lovely acronym because this is a whole pile of mess. The idea here is that we want lookup tables because lookup tables are good, but we don't want to design 50 odd tables into our database because, oh, I don't know, I'm sure Azure charges per table, doesn't it? No, it actually doesn't, but we don't want to create a table that's only going to have 2 rows in it, is usually the excuse I hear. We don't want to create too many tables because it's going to make our deploy scripts messy. It's going to, whatever, it's going to take us more time than we want. This is another design that typically people make once. The idea here is that instead of having a lookup table for city and a lookup table for province and a lookup table for color and a lookup table for fruit and a lookup table for the travel method, we have one lookup table. We have a primary key on it, which we will use for all of our foreign key constraints because foreign keys are good. We will then have another column which tells us what this actually is. And finally, we'll have a value. This isn't quite an EAV. It's got the same idea though. The problem with this is again data quality, constraints. The only thing I can do to this table is define a foreign key to it. So let's say I've got a client's table and the client has a city ID in it. And I want to have the city ID being a foreign key to my lookup table. The only thing I can do is constrain that with a foreign key to match a row in this table. I cannot, with a foreign key constraint, constrain it to match a row of type city in this table. And so you are again relying on your application enforcing its validation correctly, on somebody not getting access to the database and changing the data by themselves, and on not having any bugs when when you're populating your database or inserting data via your application that might accidentally select the wrong type to put into a table. Because as soon as you have one of those, you end up with the client having a city of red and the fruit basket having watermelon, oranges, and Johannesburg in it. You can't prevent that. The only thing you've got the ability to do is say, it will be a row in this table. I've seen this referred to as the apples, pears, and trains type design. This is a violation of relational principles. In general, you want a table to have one and only one thing in it. A client's table has clients in it. A company's table has companies. A city table has cities in it. A city's table does not have watermelon in it, nor should it have. And if I look at my city's table and find watermelon in it, I should be able to say this is wrong and fix it without trying to figure out whether my lookup is wrong or my lookup type is wrong and how many clients have got a home city of oranges. Oh, and by the way, if you're looking at this and going, is row 8 supposed to be a color or a fruit? Good question. I don't actually know. The data might indeed be wrong. That would be the one true lookup table. Please don't fall for this one. Just create the lookup tables. There's nothing wrong with a table of 2 rows in it. There's nothing wrong with a table that has 1 row in it. And there's nothing wrong with 50 odd lookup tables in a database if they constrain your data correctly. All right. That's that for the one true lookup table. Any questions?
Actually, we have some questions now from the EAVs and with the One True Lookup tables. And one user pointed out that Muck, and he pointed out the article where it came from in SQL Server Central, is massively unified code key.
I still think that was written to be the acronym. Somebody decided it was the acronym and figured out something that made it make sense.
Anyway, the question about EAVs was, wouldn't they still make sense for audit tables? Possibly.
For audit tables, they might. You're going to have a look and see what your audit table is there for. This is going to be one of those, depends on what you're trying to do with your audit table. If you need to reconstruct the row as it was at some point in time, you're still going to have a horrible time building that query. If you're tracking single column changes, it might be fine. I've used XML for audit tables. I've used full row copies for audit tables. I've had an audit table per table. I've had a single audit table for all tables. And then there's the temporal tables in the later versions of SQL that can do audit style as well. Maybe it's sure as hell better than having it for your actual database design. But before you go and EAV your audit tables, figure out what you're trying to do with the audit table. What are the requirements for it? If the EAV is going to make those requirements hard, maybe do something else. Maybe, unfortunately, that's about all I can answer.
Okay. In the case of schemaless, what about using JSON type columns?
If you need a schemaless database, may I recommend Cosmos DB, MongoDB, or one of the other document databases? They're schemaless. Please don't try putting document databases into a relational database. Please don't try putting relational databases into a graph, graphs into a document, or any other combination. You want schemaless? Cosmos DB with its Mongo API is fantastic. Use it.
Okay. Is it possible to get the whole row from EAV by joining the table twice?
No, you're joining the table to itself as many times as there are attributes. If you look at this one to fetch the row as a row, I need to query this table 3 times. Once for client, once for priority, once for reference number, or some unpivot type query. It's going to be horrible. It's going to be horrible no matter how you do it.
Okay, now we have one on the One True Lookup table. Would a multi-client shared lookup dictionary be similar to this One True Lookup table?
Oh, I don't know what you mean by a multi-client shared dictionary. If we're talking about, but the key here is if you look at your lookup tables, do they have one and only one thing in them? Does my city lookup have cities in it? Only cities. If it has cities in South Africa and cities in Japan and cities in North America and cities in Europe, it's still a cities table. It might be fine there. If my cities table suddenly has trains and automobiles in it, then it's a problem. The guiding rule here is relational databases. A table is one thing and only one thing.
Okay, that's it for questions.
Okay, let's carry on. All right, so the opposite of the One True Lookup table is we don't want any damn lookup tables. This was fun recently. I had the pleasure of fixing this mess. All of the values were stored as in enums in the application because the database sure doesn't need to know what it's storing. And so our telephone table had telephone types. Well, if you took a distinct of the telephone type column, you had null, 0, 1, 2, 3, 5, 7, and a couple of instances of strings that I don't know how they got in there. I really don't want to know how they got in there. The problem here is that, firstly, if I look at this and I'm trying to write queries, I don't know what phone type 3 is. Is it a fax? Can I phone it? If I call it at 7 in the evening, are you going to answer? What is this thing? The bigger problem in this particular example was that the enum in the application had values 1, 2, and 3 only. It didn't account for a value 5. The table had no constraints. It didn't have a lookup table, so there wasn't a foreign key. So there was absolutely nothing stopping somebody from putting telephone type 7 into the table, despite there not being a telephone type of 7. This was not fun, because it meant when we started querying the phone table from the application and the phone table from the database, we got different results, because the application was looking based on its enum. The database wasn't, because it had no concept of what the telephone type was. That's the one side of the lack of lookup tables. If you're going to put meaningless numbers into a database, please tie them to a lookup table. So I can, one, go and look up my lookup table and say, oh, phone type 3 is a fax machine. I don't know who still uses fax machines in 2018, but I know some people still do. Lawyers probably. But at least I know I'm not going to phone it and expect you to answer it. If I phone it, I'm going to have a conversation with the machine. The other side of the lack of lookup tables is this, where instead of a lookup table, we put an actual value, the string, into the table. Of course, we're not going to bother putting constraints in place, because who needs constraints? Our application knows what it's doing. And so, well, if we look at this, how many cell numbers do I have? You see, in South Africa, we call them cell numbers. You're not going to find anybody in Johannesburg referring to it as a mobile number. They're cell phones here. Other parts of the world call them mobile numbers. And let's not even start about that misspelling of home. Good luck trying to figure out how to get hold of somebody. Please, if you've got lookups, either a lookup table with the values in it, or if you absolutely insist on having the types in a string column, put a constraint on it and constrain it to the expected values. If you don't want a table, you need a constraint, one or the other. But allowing free data to be put into a column that you are then going to look for specific values of is a recipe for a code and data nightmare later on. Because what will happen is that your reports simply cannot reconcile. The report that doesn't filter by phone type returns 2,000 rows, and the report that filters on the telephone types that it's expected to have returns 1,600. And lots of work trying to do the data cleanup later. Data cleanup is horrible. You don't want to be trying to do that. Right, so that's the lack of lookup tables.
No questions on that.
No question. Excellent. Moving on. Many-to-many joins are really handy when you do indeed have many-to-many data. But I've seen a whole bunch of design systems recently that put many-to-many between tables that are not actually in a many-to-many relationship. And one of the ones I saw fairly recently was the customer address combination. Now, this looks actually okay at first glance, because you might have multiple customers at the same address. For example, the company I work for, we do a lot, most of the people who work at head office, when we order from Take-A-Lot, which is our local Amazon equivalent, we have the stuff shipped to head office because there's somebody here all the time. It's easier for me to ship stuff to my office than to ship it to my home, because I'm not home most of the time. So there are roughly 100 staff at head office. So there are roughly 100 people at Take-A-Lot, let's say, that have the same address. Two problems here. Firstly, when I enter an address, are you going to give me a drop down of existing addresses? Because if you are, that's a privacy nightmare, because you've just shown me where all your customers live. I don't know who lives where, but I still have addresses. That's not ideal. Okay, no, so you're going to make me enter my address and then do some complicated matching to existing addresses so you can try and do this many-to-many mess. So one of the 100 staff at head office who's having his parcels shipped to head office is relocated to a client, and he goes into the application to change his address so that it ships to somewhere else. What happens to my parcels that are shipping to the same address? Are they suddenly shipping to where he wants them shipped to? This is one of those areas where you need to look at this and go, does this actually make sense? And I've seen this recently on addresses. I've seen it on phone numbers. I've seen it on cars, which was really entertaining. Because I promise you, my parents may have 2 cars between the 2 of them, but that doesn't mean they drive the other one's car. If you've got a many-to-many design, make sure that it actually does make sense. Does a customer have multiple addresses? Yes, that makes perfect sense. Does a single address belong to multiple customers? Probably not. This is starting to make less sense. And if you try to enforce that, when people start changing, correcting, modifying addresses, you're going to be in a world of hurt with the data cleanup that you're going to have to do. Right, unnecessary many-to-many. Oh, one other thing on this, it makes it very easy to accidentally have duplicates. Because I've got multiple address, I've got one address to one customer. I've got almost the same address to a different customer. It's very easy to end up with duplicates in the customer address table because, as you may have noticed, I haven't bothered putting a primary key or a unique constraint across the combination. So I could easily end up with multiple customer addresses which are the same, which when I start pulling reports just means my data starts duplicating like crazy, which is of course a whole bunch of other problems. Do think before you dump a many-to-many in. This one is also not a lot of fun to fix. In fact, once the data gets into a bad state, it's nearly impossible to fix. Laughing at a question or laughing at me?
No questions.
All right. 20 minutes left. I'll keep the entertaining ones for the end. Bitmaps in a database, because nothing quite shows how intelligent I am or shows my computer science degree than doing bit manipulation in a database. Please don't. Please, please, please just don't. This is in fact the opposite of the previous question, the previous bad example. The thing here is that I have an employees table, I've got a training table, and I actually do need a many-to-many join between those 2 tables because one employee can have multiple training courses. Whether he's on them or has completed them is irrelevant. And one training course is assigned to multiple employees. So this is a many-to-many relationship. But some people have taken the unnecessary many-to-many a little too far and decided that they really don't need a many-to-many relationship at all. Instead, what we will do, we have, I think that was 32 different courses. So for each employee, I'll just map 1 or 0 for each course and store it as a bitmap, which means that Bob's 4.2 million actually means he's only attended 2. Here's a fun question for you. Think about how you're going to determine which training course Joe has done. How are you going to determine which of those people have done a particular course? The way you end up doing this is with bit filtering. Essentially, the way you have to query that is select from employees where registered training ampersand for the bitwise and a integer value, and you compare that to greater than 0. Let me just see if I've got Management Studio up quickly. I do not. I'm going to load Management Studio up and actually write that query out so you can see just how horrible it is. Just give me a minute so I can load this thing. I wasn't planning on doing demos, but this one really needs to be explained, needs to be shown, not explained. Yes. And of course, Management Studio has been appallingly slow. new query. And you need to know your Boolean maths when you're doing this. So our bits go 1, so 0001 is 1, 0010 is 2, and so on. So if I want to find out which of my employees is registered for the course that is marked as 4, I would have to do that. This is a bitwise AND. So let's say that we've got a employee with a registered training of that. This means he's attended course 1 and course 4. If I AND registered training bitwise with 4, what I get out is 0, 1, 0, 0, because 1 and 0 is 0, 0 and 0 is 0, 1 and 1 is 1, 0 and 0 is 0. This is greater than 0, so that particular row returns true here. This is not saugable. This cannot be indexed. That's the first of your problems. This will hence be slow because you're doing table scans every time you want to run this query. The second problem is that this is not bloody intuitive in the slightest. I mean, seriously, if you were looking at a new system, which would you prefer? This or I'm just going to shortcut the query. I'm sure you can get my meaning. I would guess that this is a lot easier to understand than this. If this is easier to understand, you probably should be designing CPUs because you're good at that level. But for most people, this is a little bit easier to understand than whatever the hell this has become. I had a client with this recently, and in recently I mean in the last couple of years. They had this all over their database, and it was one of the causes of frequent deadlocks. And by frequent, I mean 2,000 a day. This was not at all pretty. All right, that's bitmaps, please. I know it makes it. I generally see this when people want to look really intelligent. They design this into a database. It doesn't actually do that because it's such a bloody pain in the neck. Everybody who works with the system afterwards is cursing their name for the rest of the year or the rest of their lifetime. Any questions on bitmaps?
No questions on bitmaps. Hopefully nobody does that. Like you said, some people do, but
I've seen them. I've seen them in real systems and more than once. All right, 10 minutes. I think I've only got 2 or 3 left. Data types. Let's just nvarchar max everything. What could possibly go wrong? Yeah. I hope I don't need to explain why this is bad. This, by the way, you will often get if you use entity framework, don't do the data type in your model and then code first create the database from your model. You will get this kind of mess. Something which is nvarchar max everywhere it does not need to be nvarchar max, which is pretty much everywhere. I'm not going to tell you what this table was. I blurred out its column names for a reason. I will, however, point out that the second column down contained only the values Mr., Mrs., Ms., and Doctor, which I will point out is no more than 4 characters long. It was n varchar max. This is not indexable, strangely enough, because it's an n varchar max. Your n varchars, your max data types, because they're stored out of row, because they can be stored out of row, they are slow. They are appallingly slow. When we cleaned this system up and pulled all the n varchars out and turned them into, varchar 10 in many cases, varchar 200 in the worst case, the performance on the system went from this is unusable to this is fantastic. And that was from changing the data types. We didn't even have to index it afterwards. We would have. We didn't have to. Of course, this isn't the worst you could possibly see. This could have been in text. The old SQL 2000 deprecated Unicode max data type. If you've got a system with n text in it, I am so sorry for you. Please don't inflict that mess upon the world. I see big ints for numbers that get no larger than 200. I've seen floats for financial values more times than I want to count recently, which led to the entertaining situation recently where 1/3 of the rows in the table did not set, if I added up the subtotal, the tax, and the discount did not match the grand total. Because floats are approximate data types and 0 is not guaranteed equal to 0, and there was floating point inaccuracies. I personally like my financial values precise because I don't particularly like accountants yelling at me. If you do want some entertainment in your life, put floats in your accounting database and then make sure you're on holiday when the accountants try to run the year-end reconciliation. Please, appropriate data types for the appropriate data. It doesn't need to be n varchar max. If it's not getting above 300, it also doesn't need to be bit. I'll take any more questions at the end as well. I'll push through. I've got a couple more to go. Oh, this was something I worked with many years ago. This was unfortunately a real system. I have, of course, reproduced it. I don't have access to the real system any longer. This was a logistics company. This was a logistics company's waybill table that gave all the information as to where they took shipments from and to. They had no constraints whatsoever, which led to funny things like, the dispatch location be null. It got shipped from somewhere, but I don't know where it was shipped from. I do know where it arrived, so at least it arrived. It gave me interesting things like arrival dates in the Middle Ages. Yes, that's 1018. I had things like dispatch dates in the far future, 3018. I think that arrival date's also wrong, because if something arrived in 2001 for a system that's been written in 2018, there's obviously a problem here. I had dispatch dates after arrival dates. In other words, the parcel arrived before it was shipped. I'm not a fan of time travel in my sci-fi stories. I certainly don't want to find it in my databases. We had stuff that was shipped from nowhere and arrived somewhere. We had stuff that was shipped from somewhere and arrived nowhere. We had arrival dates that were null, but things arrived. We had dispatch dates that were null, but we knew it had been sent. We had masses of null. We had a mass of -1. We had 10 tons shipped in no containers. The system was so bad. I do not know how that logistics company is still in business, because they are. It's been almost 20 years that logistics company is still in business. I do hope they've cleaned their database up, because at the time that I worked with it, it was such a pile of mess that there was absolutely no value that you could get out of that database. Because if you'd like to try and bill somebody on this mess, please do tell me how much they should be billed. Oh, this is also showing up a lack of lookup tables. I will also point out, for those who are not familiar with South Africa, that there are 2 locations in South Africa which are referred to as the waterfront. They are 1,400 kilometers apart. It might be useful to know which one you're supposed to be going to. Also, from that same system, because bad examples breed more bad examples, when you have a unique constraint that is your primary key, you know that inter-identity primary key auto increment column, and you don't bother putting unique constraints anywhere else in your system, and your unique order reference number wraps after 8 months, you get this kind of mess. I'd like to know which of those items were actually in the same order, because there are 2 orders there. They happen to have the same order reference number. Now, sure, I could do some work on the order ID and try to work out which combination of things actually belong together. But by this point, I'm probably just going to give up and tell you that I can't get any meaning out of your billing system either. Would you please like to employ a database designer to actually do some design on your system? Please put unique constraints in your database where they belong. It is impossible for something to be delivered before it was shipped, unless you have time travel. It is impossible for something to be shipped 300 years ago. Unless, I don't know, maybe you're one of these ancient shipping companies. It is definitely impossible for something to be delivered in the year 6000. I cannot ship -1 kilograms. If you can ship -1 kilograms, the local physics department will be fascinated. There will probably be a Nobel Prize as well. It is impossible to ship 10 tons in 0 containers. It is impossible to ship -1 containers. Please put these constraints into your database. Yes, your application has constraints. Yes, your business layer has constraints. Put them in your database as well, because if you don't, sooner or later, some garbage is going to slip in. If you are going to inter-identity primary key on your tables, and I do that on most of mine, something else in that table needs a unique constraint on it. Because if you don't, I promise you, you're going to have duplicates. The only question is how many and how soon. I had a situation recently where a table had 215 million rows in it. I will point out that this was a telephone table. I will also point out that it is unlikely there are 250 million unique telephone numbers. Well, it is frankly impossible for there to be 250 million unique phone numbers when you only have 10,000 clients. People don't have that many phone numbers. When we deduped that table, we had less than 6 million. I should note that less than 6 million meant we still had a whole bunch of duplicates, but that was mostly in the case of mistyped duplicates. You know, the code and the number together or separate. We went from 215 million rows to 8 just by doing a distinct on the columns which were not the primary key. Please put the unique constraints there. Your future maintainers of your system will thank you for that. That's my series of rants for the night. I hope you have learned something from all of my painful lessons over almost 20 years. Do we have any questions in the couple minutes we have left for tonight's session?
Actually, there's comments, but mostly people smiling. And there's one comment I have to point out. Somebody said that they actually worked with an MIT grad who insisted on using bitmaps. I hope they didn't have to work with them too long.
I did mention it's one of those, it looked really smart. Yeah, not saying too much about MIT grads, but yeah. I don't want to insult too many people tonight. I think I've already done that. Cool. Well, if there's no questions, then I am actually done. I do thank you guys for listening. I'll return this to the moderator in case he's got any final wrapping up he wants to do.
I appreciate it, Gail. You deserve a rest. Gail came to us directly from training another class for several hours, and she was working. She's been up. She needs some rest now. Anyway, thank you for a great presentation. I think people enjoyed it. They didn't have as many questions, but they enjoyed seeing, I guess, other situations and reminiscing about things that they may have seen themselves. And hopefully it'll they can learn from these if they haven't seen them before and say, yeah, okay, I don't need to do that, or they'll get ready to do something and go, wait, I need to do something else.
One thing I do need to mention, these are all from real production systems that I've worked with over the last 15 years. These are not made up. Every one of these actually existed.
Yeah, this wouldn't be very fun. Anyway, we appreciate it. And next week, Down Under, we'll have a great session coming up, and it didn't get promoted very much, but please attend that. And we should have this session up in probably a day or two. I appreciate it. Thanks, Gail.
Thank you very much.
Bye.
Yes.